Okay, guys, let's continue our discussion on load combinations this time. So, in my last video, I discussed the strong reduction factors. So, tonight I'll be doing in, giving you some information over the ACI load combinations and as well as the NSC load combinations. Okay. So, for ACI 1999. So let's start with ACI 1999 load combinations. We notice that this is the equivalent strength design method. We've been using the old codes, okay? So the combination is basically uh, enumerated or summarized into this basic wind, earthquake, earth pressure, fluid pressure, impact settlement, etc. Okay, and notice that here, as far as the wind and the earthquake is concerned, the decrease in allowable stress okay, is introduced here. Okay, so that means gravity is equivalent to 1.33 degrees in allowable stresses. Okay, so that this is the reason why we have a 0.75 value there. And the rest are strength design load factors or overload factors we've been familiar with as far as the old code ACI code is concerned. Now, take note of this that the application of a 10% increase is made on this particular ACI 99. Okay, so that's why if you will notice, basically the wind and the earthquake are just the same, but if we convert now the wind load into the earthquake load, it became 1.87 simply because this was multiplied by 1.1. Okay, so it's 1.1 of 1.7. Okay, that's why this becomes 1.87. So the reason why I'm telling you this is for you to be able to take the history, to capture the history of how the load factors were adjusted based on probability principles and sometimes also some experts' judgment, but still based on statistical studies they made when they look into how the forces of wind and earthquake really match the assumptions uh, with that of the actual nature given to us by earthquake and wind histories. Okay, so for earth pressure, which is designated as H, okay, H is earth pressure. So this is just the same as live load. Okay, so if you notice, it's still also factor 1.7. For fluid pressure, it is said here that Simply add 1.4F to all load combinations that include the live load. So note that we add 1.4F to all combinations that include live load whenever fluid pressure is to be considered. And for impact, we can substitute simply your L into an L plus I because sometimes impact L here constitute vehicular loadings. Okay? Because vehicular loadings are considered live load as well. So settlement friction, pressure, temperature, anything that has something to do with volume change in terms of T is not considered here as a part of the debt and a part of the line. Okay, so it's just like uh, considering it as a part of your basic load tenant. Okay, the estimated impacts above should be based on a holistic assessment of such effect during at service. So to avoid approaching the value of 1.05 D plus D1 live load is negligible. Okay, so this is the reason why there's an asterisk here. Okay, so that's it for 99. So let's before we do the NSCP edition of this code, let's look back to ACI 2002 first. Okay, so for ACI 2002, basically the strength design uh, is a little bit adjusted in terms of basic, but there's no adjustment. Okay, no adjustment. But in terms of wind, notice that the 0.75 was not okay. It's not included here in wind. Okay, so what happens is that your wind, which is originally 1.7, the W was reduced to 1.6, but without the factor of 0.75. Okay, so without considering increase in allowable stress, and that's 1.33. So this is again the 1.33 increase because the reciprocal of 1 over 0.75 is 1.33. Okay, so this is not included. Consider the increase. And of course here, instead of having a 0.9D plus 1.3 W, okay, so this becomes 0.9D plus 1.6 W. Okay, so what's the difference between having a 1.3 W? Okay, so the difference is that is on directional factor. Okay, so if you know that the directionality factor, which KD, which is equivalent to 0.85, there's a danger of having having to reduce this when W is already multiplied by 0.85. Okay, so that's the danger. So where wind Julia has not been reduced by direct, it shall be permitted to use 1.3 W or instead of 1.6 W. Okay, so here this is 1.3 W. So here it is 1.6 W. If W has not been reduced by a directionality factor. Okay, so take note of that. In your computation for your formula for your Q has something to do with the directionality factor, then you have to take note of this. Okay, so on earthquake now, so again a change is you don't have to consider already you don't have to consider the 0.75 on 1.0 E. So slowly but surely the strength design approach is now being phased out. Okay, the strength design approach is now being phased out because on the earthquake 0.75, which is again the increase of 1.33 on the allowable stress, is no longer considered. But take a look, your earthquake here, which is 1.87, was now reduced drastically to 1.0 E, but it is again stated here that based on this, your earthquake load must be at the service level seismic forces. Okay, so if it is on this level, you have to substitute 1.0 E with 1.4 E. So this must be 1.4 E in case your earthquake is at the service level seismic forces. The problem is, the question is the base shear formula based on service level seismic forces. So that is the big three there are the considerations of the parameters you use based on service load levels. So again, that's one thing we need to take it to heart in using this model. So U is 0.90 plus 1.0E, which just actually the same with your previous 0.90 plus 1.4E. You can change your 1.0E to 1.4E again if your E is based on service level seismic forces. So for earth pressure, H, for fluid pressure, F, for impact, I, so everything was just the same. Okay, I think there's no difference between this uh, part here. Okay, so no, basically no difference. So that's it for the ACI uh, 99 2002. So we will try to compare it with the more newer code later. So I'd just like to end my discussion first here and discuss to you some of the versions of the NSCP on my next video. Thank you very much for listening. I'll see you in the next video.